Welcome back. This is Psychology Applied to Work, Lecture 10, Psychological Tests for Work. Let's get going. All right, this is the beginning of Unit 2. You may or may not have already taken the test for Unit 1. If you did, I hope it went well for you. Let's recap what we covered in Lecture 9. So Lecture 9 was the third bonus lecture, and we talked about why we work. We talked about the obvious, which is for resources, for money, for benefits, for tangible things, and for reward and for experience. And we talked about happiness and to what extent that does and does not correlate with money, and to what extent people really should and do or do not pursue happiness. We talked about sense of community, pro-social, affiliative, in-group belonging. And we talked about a sense of duty and how that may manifest differently in different cultures. It is certainly a cross-cultural phenomenon. And we dived into meaning and talked about how we, as a culture, are struggling with a common framework by which we even define meaning, and how for many people it's a struggle to find meaning in their lives, and how important meaningful work is in that regard. And then we talked about strife, and to what extent carrying a burden is actually an important thing, and whether we as a species are perhaps at least partially hardwired with the expectation that our life will have a certain amount of strife to it, and when it doesn't, we may have systems that maybe not work quite as well. Interesting topic. Hope you thought the lecture was interesting. Today we're going to get back into the nuts and bolts of industrial and organizational psychology and talk about psychological tests for work. And predominantly these are tests used for things like employment selection, to try to determine who is best for a role. And topics along these lines include validity, which is arguably the most important thing, and reliability, and we'll explain these topics as we go. And we'll get into the different types, different methods of testing. We'll talk about cognitive tests, and we'll talk about personality inventories, or tests to determine things like personality traits, as well as other tests. Okay, let's get into it. Employment and selection. So the most obvious thing is, if you're going to select people for a job, you need to have a method. But when you look at it and you think about it and you apply some science, you want that method to be objective. And that method could be some forms and a process. It could be computerized tools. Whether it's a method or an instrument. What you're really trying to do is reduce the uncertainty in your decision making, to better predict whether a particular person is going to be able to perform the job that you're considering them for, and to what extent, how well could they perform that job. And this is something that this is another one of those $1 trillion problems that organizations are constantly battling with, and constantly looking for better methods by which you can more accurately predict whether somebody is going to do well in a job. Because when somebody does poorly in a job, it has a kind of a multiplier effect. I mean, it can be disengaging to the people around them when somebody's not pulling their weight, or they're just failing. Depending upon what that person is doing, they may be doing work that is critical as part of some workflow, and so their inability to do their job properly actually can result in large groups of people basically either also failing in a worst case, or more often what happens is, if somebody is not really up to their job, so to speak, isn't able to perform at the needed level, other people have to step in, and so their work gets more difficult. It's bad for motivation, it's bad for retention for the other people, and it's frankly bad for the people that you pick. You pick somebody that turns out not good for their job. It seldom goes really well for that person. So these things cost a lot of money, they cost a lot of lost time. And so this is something that organizations, especially for-profit corporate structures, they take this very seriously, and they're always looking for ways to improve this. That said, this is very difficult, and there is a regulatory or a law framework around these, and some liability framework around these, that you can't just you don't want to be too innovative in your selection processes if you have the potential for creating systems that might be deemed to be unfair, and you could set yourself up for lawsuits or frankly to run the foul of employment law. So there are some constraints on the innovation in this space, but it is a space that is constantly being looked at, and perhaps if you have a long career, you might see significant evolution in this space. I certainly have in my lifetime. Okay, so you need objective tests. You're trying to reduce uncertainty in your hiring decisions. This is one of the first applied psychology things that went into work. I mean, this was Munsterberg. You recall that Munsterberg and Scott came out of Wundt's lab. Scott's generally considered the father, but you can look at Munster, and the father is an old term. Founder is term we would use today. But some would argue that Scott and Munsterberg, maybe jointly deserve the title of founders of IO psychology. But Munsterberg was the first to really look at systematically applying psychological methods to selection decisions of employees. And not only was this one of the first things that IO psychology did, it's also one of the main focus areas of IO psychologists in the field today, at the applied level, at the practice level. This is still an area that is not sufficiently solved, so to speak. There's still a lot of money left on the table, so to speak, due to poor hiring decisions. That it does and probably will remain a primary focus area for some time. The tests that you design, you typically, your selection tests, and test is sort of a broad word. I mean, this doesn't mean there'll be multiple choice things. The various situational and structured interviews that we'll learn about in the next lecture, would be considered, testing. But as you design them, you're typically anchoring them to some extent to a job analysis, or at least to something generalized in terms of what kind of knowledge and skills you might need. You need them to be fair and standard, and standard, it really means they're consistent and they're uniform, they're standardized, and anyone who is performing these tests needs to accept the responsibility that the administration of these tests carry with it an ethical and a legal, to some extent, burden to make sure that they are standardized, and so that these tests are done fairly. It is also critical that these tests be valid, and we'll dig into the concept of validity in a little detail very shortly. They need to be reliable, and we'll talk about that. Obviously, you need to, as best as you can, make them objective, which means, among other things, that if you're scoring them, you developed some way to assess somebody's skill that it was mapped to the job you're hiring. You want to reduce the ability of a biased scorer from applying their bias. So that you want, in some ways you do that is with having multiple eyeballs involved, having multiple, have a panel involved in this, but you also want to constrain the way you construct the scoring, the way you sort of develop a rubric, so that bias, where somebody just wants to hire a certain person, but you can't make it work out in the numbers, that they can't just bulldoze their way through and hire who they want. That you want to keep it objective, and then you want to do that with established norms. And so one way to look at that would be, if you've developed a selection test method that, say, had 30 different questions you posed to somebody and a reasonably objective way of scoring it. If it was something you were going to use for quite some time, you would want to establish that if you have a pool of similar applicants, that you're going to see a distribution of scores that's repeatable, so that you're not dealing with something that you can't statistically show is objective. So if you use a test method and you used it for several years, and you took some time to do some sort of matched grouping to your applicants, you would want to see that there is a distribution in the way people score that paints a picture of normal variability, and not something else. And it's a difficult thing, and we don't have to get too into detail, but hopefully you get the idea. Okay, validity. Let's back up a little bit before I get into this slide. Yes, I'm sure there will be questions on the test that are related to this slide and the different types of validity, and we're about to get into those different types of validity. But I should, caution you, at least with my opinion. I find the nomenclature, the way these things were named, to be, shall we say, suboptimally intuitive. That they are not, for me anyway, things that are self-explanatory. And so they are a little jargony, and that does make them less accessible. And also, this is not something that, unless you plan on a career where you're developing these tests, or you're doing research that involves testing, it's not likely that you're going to encounter these terms again. So you have my sympathy to some extent. That said, some of this is likely to be on the test, but it is an open book and an open note test, and stuff's not difficult, as I hope you'll see that, but there is a kind of arbitrary nature to some of this naming. At least that's my opinion. Hopefully, I'm not making too many people that might watch this lecture that disagree with me too angry. Okay, so the concept is pretty straightforward. Is you're doing tests. How do you know that your tests that you're doing are actually giving you a prediction that's relevant to what you really care about? So you take something like the ACT or the SAT. Are you actually just testing somebody's ability to answer multiple choice questions in a verbal or a mathematical frame, or are you legitimately determining who is going to be a success in college and who's not, and to what extent can that test be used as a filter, and how many false positives, so to speak, and how many false negatives are you going to get? The validity is a critical thing. It's the most important thing if you're going to implement a test like this, is that you do your best to make sure it's valid. And then validity gets broken down into different ways, and now we're getting into the jargon here. So criterion related validity, and there's two types of these. There's predictive criterion related validity, and there's concurrent criterion-related validity, and they're not, these aren't difficult concepts, but they are a bit obscure in the wording. So the predictive validity is really just, does the test you're doing, and again, these are employment / selection tests, but this validity and predictive validity, these apply to all sorts of psychological tests that you might be trying to develop and use, but we'll stick with this selection as the application. So does your test legitimately predict the performance of new hires? And if it does, then it's predictively valid. And then the concurrent is, okay, you've got this new test method. So you've got a company, you've got 1,000 employees, you have 150 employees that are all doing this job that you've developed this test to determine who is best able to do this job, and you want to use it for hiring because the company is growing and it needs to hire 50 more of these people. So the first thing, the predictive validity, is, well, what happens if you use it and you use it to select your 50 people? How well do they actually do? But the concurrent validity is, okay, why don't you take that test that you claim is predictive, and why don't you give it to the people that are currently in their job and see if it even tells you that they ought to be in their job. And if your test says, well, actually, half of these people are not qualified, well, how are they performing? Maybe they're performing just fine, and so maybe your test is not concurrently valid, and that's a mark against it. So predictive and concurrent are the criterion related, or the criteria, and the expectation is, if you're going to create a test and implement it, is you want it to be both predictively valid and concurrently valid. So hopefully this is making sense. And then there's rational validity, and naturally there's two versions of that to keep it being complicated and a bit opaque. There's content rational validity, and there's construct rational validity, and it's typically not called content rational validity. Usually they take the rational out, so you'll hear the term content validity or construct validity. And a way to look at this, to sort of, is if you remember the what versus the how, and you remember the task was the what. What does a person actually do in the job, and the how was how they go about doing that. And one was like task performance stuff. But then there's the job you do, but then there's the skills you need to do the job. And some tests will be looking at, can this person do the task? And some tests might be looking at just, does the person have the skills and knowledge that you need in order to learn and do these tasks well? And they're different things. So the rational validity is really related to the content that is not direct to the task, so that's more towards the KSAOs. So the knowledge, specifically the knowledge and the skills. Content validity is, does your test and the content of your test match the content? Does it test for the content of knowledge and skills that a person needs to do the job? So you can look at it as, to the extent that it tests for the KSs of the KSAOs, it's content valid. And then construct valid is, does it correlate, with the previous tests that you thought were working? If you have tests that you're replacing, or you're having a test that you're adapting to a slightly different job area, but it's very similar. To what extent does your the way you've structured your test, the way you've constructed your test, does it correlate well with tests that were done prior to it, or maybe tests that are done by other people that where those tests are considered valid? So this is not, to me, this isn't like super crystal clear things until you've lived with it for a while. But again, make note of where these things are. Take a look at the textbook's definition of it as well, and then I'll make sure that any test questions related to this, it's very clear that if you've got these slides and you've got the areas of the textbooks marked, you'll be able to figure it out. So let's keep going. Face validity is pretty straightforward. This is basically, does the test, on the face of it, seem appropriate when you take it? So if you're in high school and you're taking the ACT and you ask yourself, okay, I'm being asked these questions in English and in math and in science, and to what extent do I feel that these are tests that are relevant to me, relevant to colleges, for me to prove that I'm ready to get into a college, or to prove that I'm ready to do really well or okay or whatever. Does it seem on its face to me, the test taker? So that's face validity. And to some extent, this is another check to make sure that a test is a good test. But in another extent, this is to make sure that you have buy-in, that people don't feel like they were cheated because they had to take some obscure test. You went for a job at McDonald's and they asked you to do a calculus proof. It wouldn't make much sense. And then if they said they weren't going to hire you because you couldn't do the calculus proof, you might feel like you were cheated and that maybe something bad was going on, and maybe they deliberately just didn't want to hire you, and maybe you want to explore getting a lawyer and see if you have any kind of litigation resource. So anyway, lots of reasons why you want to have face validity. Do the test takers trust that this is doing this is what I was just saying. Okay, and then how well does your overall test approach generalize? Is this if this was machine learning, this would be like making sure it's not overfit, which probably doesn't make much sense to you, but I'm a nerd. Anyway, you want to look at these different dimensions of validity as a way to help your confidence level, or to tell you whether you need to keep working at it before you might consider implementing this. And a test that seems to work really well for a certain type of back-end software developer, but the approach just goes to crap when you try to use it for front-end software work. Maybe because of that failure to generalize in that regard, that is something that you'd want to explain and make sure isn't a problem with your test being too narrow. And it's not crystal clear exactly what's the right path forward and how much generalization is actually needed. But you can look at all of these different validity dimensions as ways to help make sure that these tests hopefully do what they are setting out to do, which is to hire the best people. And as I said earlier, this is an area that continues to evolve because it continues to be imperfect. So validity is the most important thing. I would argue it is perhaps the hardest thing, and the things that are more valid than others often end up being quite cumbersome as well, which presents their own challenges, and we'll talk about that as we go. Generalization is does this approach work for other types of employment, other types of jobs, other generally situations, and as I said, this validity is the most important requirement. Okay, reliability. This one's maybe you thought that the predictive and concurrent criteria and validity was super easy, and that you weren't put off by the arbitrary wording and all that. And if you were, you're a better person than me, because if I go away from this stuff for too long and come back to it, it's not I can't just rattle it off the top of my head. Anyway, reliability is something that's a little bit more straightforward, in my mind anyway, a little bit more intuitive to explain. And really, this is about if you think the test is valid, like if you developed an ACT or an SAT like test and you did a bunch of work to show it's valid, but it was unreliable, that might mean that a person taking it at a certain time of day in a certain physiological state might do markedly better than if they were, say, just a tiny bit less caffeinated or a little bit distracted. I mean, you want to make sure that you're not creating like a narrow situation specific test that needs a particular frame of mind in order to work. And if you do that, then you have an unreliable test, because those are often those parameters. The headspace of your test taker is often a parameter that you don't have a lot of control over, and it's really not in your best interest to filter out people that just happen to not be in the perfect headspace the moment you took the test. And hopefully this will make some sense as we go. So you're looking at test-retest consistency. That's what you want for a reliable test. And you want that test-retest consistency to work across subjects and across time. So as you give this test to a whole bunch of different people, you want to get a distribution pattern that makes sense. Your people really qualified, you hope, will consistently score well, and those that are not so qualified would consistently score low. And then over time, is if you brought those people back and had them take the test again, or say a test that was almost the same, was architected the same, but it had, say, a different set of questions, but they were still very similarly worded questions, so you don't give them the benefit of having seen the questions before. You want to see that the scores are similar. So you something like a ACT or like an IQ test. You don't want them to have radically different scores if people take them once every couple months, and that is it's fairly, those tests that I gave an example of are known to be pretty reliable tests. I mean, if you take the ACT and you get a 20-something, you actually have to do something for the most part. If the next month you took it again, if you could take it once every month, your test score might creep up a little bit because you might be deliberately trying to work on these things. And then in some respects that would actually reflect that you have improved some of your knowledge, but you wouldn't expect to see a radical shift in your scores, because those tests have been architected for decades for reliability. So there's 4 ways of looking at reliability. The first one is test retest, and that's really like at time number 1 or time number 2, you should get the same types of scores if the same group is taking them. It's another way of looking at reliability, and that's what's called equivalent forms. So if you have a test that says 100 questions, and if you come up with another set of 100 questions, but they are still the same sorts of questions, they're just sort of reworded differently, you'd want to see similar scores, to which case you would have what's called equivalent forms, and that gives you the ability to protect your test in case somebody gets it out and can memorize and gives it to somebody who can memorize the questions. And it also helps you with people who might want to retake the test, where they're not going to just see the same questions and benefit again from some potential memorization. Another way of looking at test-retest reliability is can you split it? Could you if you have 100 questions, can you randomly pick 50 and the other 50 and give that half test to people? And do the scores between your 2 half tests correlate really highly? They should, if you've got a good, reliable test. Now, as you go to half the questions, your statistical power is going to get a little less, and so you'd expect to see a little bit more variability, but you would still expect to see, if you made a reliable test, a very high correlation between the two halves. And then a way of kind of looking at that beyond the halves and quarters and eighths is, how internally consistent. You should see, wherever you slice and dice your test, you should find good correlation in scores for a given subject and a distribution pattern across a group of subjects. So you want test retest reliability. You want to be able to have more than one set of questions. You want to be able to randomly split the test in half and still get the same results. And overall, you want the whole test in all of its pieces to correlate well with each other. So hopefully that's pretty straightforward for what we mean by reliability. Methods of testing. So there's a lot of ways you can do a test, and this will be pretty straightforward. So a common one is a simple speed test. You have 1 hour to complete these. You may have come into this lecture having completed unit test 1. Maybe you're working ahead a little bit, I don't know, but if you've already completed it, you had 90 minutes to complete 50 multiple choice questions. That was a time limit test. That was a speed test. It wasn't really a speed test in the sense that we were trying to filter and rank order by who was able to do it the fastest. That's a little different. If it was 500 questions and 10 minutes, that would create not just who is accurate, but who completed the most tests, the most questions, and did them accurately. And so you would have another way to dimensionalize test performance that way. So those are two different things, but they're both time limited tests. And then you can look at it as, okay, what about forget time for a second, what about just really difficult questions? And some of them are just going to be beyond people's ability to answer, and just how many can people get done? Here you go, you can spend the whole day, and there's only 10 questions, but we've yet to have anybody get all 10 answers right, and how many you get right might be an example of your knowledge and skill level. So that's called a power test. And then you can obviously do a test that you give just to one person. They come in, you're considering them for a position. You put them in a room and say, here, do this test. But you can also do group tests, which is what the ACT is, which is what will happen when you have an in-person class, and on a Tuesday everybody is in there taking the test at the same time. Pretty straightforward stuff. You can do paper and pencil tests. You can be on site at a computer, or you could be off site, either on a computer or on a handheld smartphone computer. And then there's CATs, there's in the K through 12 system are sort of cat-like stuff where there's a progression where the software basically keeps feeding you harder and harder questions until you find your limit, so to speak. And there's a bunch of different ways of doing this, and this is an interesting and exciting evolving area. The benefits is that this can save money, take less time, and give you sort of more optionality and ways to explore people. So if somebody's just not at all qualified, you can get them in and out of there really quickly, and if they're really, really qualified, they can really keep going, and you can get a real measure of how far their knowledge goes, depending upon how it's set up. Okay, so let's talk about cognitive tests, and these aren't just IQ tests, but they are, they're generally bucketized into things like how well you think, how fast you think, how well you can remember things, and that sort of thing. On the upside here, or in defense of these tests, I guess, however you want to look at it, these are considered to be valid tests. The cognitive ability, a test that if you get a group of people and rank order them by cognitive ability, that is considered one of the best predictors of future job performance. And then there's a lot of, within psychometrics, within the world of psychological testing, there is a decades and decades of data backing this up, that as a predictive measure, cognitive tests are valid. But, and this is a big but, just because one factor is predictive, that doesn't mean that you should use that as a filter for your candidates. Or it certainly doesn't mean that you should use it as the only filter for your candidates. Not just on the sort of moral and fairness grounds that there might be candidates that didn't do well on this cognitive test, but they have really high strengths on all the other factors that might be harder to test for, and that it's unfair to them that you have this one filter, that if people get through that filter, they generally perform well, but the people that you cut, there's a lot of good performers in there too, and that's unfair, and it disadvantages those people. That's one argument. That's the moral argument. The other side of it is the straight out organizationally selfish argument, is because that method of cutting literally leaves a whole lot of qualified candidates out. It's a lazy cut, and if you're inundated with applicants, and you don't even have the time to get through your applicants, something that is a good predictor, or like a cognitive test, could be justified outside of the unfairness aspect of it, simply because it's such a good predictor. But few organizations are in this situation where they are simply inundated with super qualified people, and the life data that shows that people who might not score really highly on a cognitive test, but might end up doing spectacularly well for your organization. The reality of that is quite compelling, in that organizations that ignore candidates because they might not score high on a particularly set up cognitive test, they're disadvantaging themselves as an organization as well as the people. So you want to be careful about how you use this. Recall in previous lecture the tendency of social sciences to love linear regression lines without showing the underlying scatter plot. Recall that x-axis is IQ and the y-axis is a aggregate performance measure of like 1 million or more people in Denmark. And notice that the highest red dot there is not on the farthest right side. The highest red dot, in fact, the highest few red dots are grouped around closer to the average IQ than the genius IQ. And yes, there's a linear trend line there. Yes, if you get a large enough scatter plot, the statistics tell you that there's a correlation there. To draw a flat linear curve tells a incorrect cartoonish message, and it not only disenfranchises a whole bunch of people who might be, that if you give them the chance, might be one of those red dots near the top, regardless of what their IQ is, because look at the left half, look at the upper left quadrant, and all of the higher performing people that are also on the low IQ side. So if you want to be lazy and quick, cognitive tests are good predictors, but you will leave a lot of opportunity, and you will be acting in a manner that's really unfair. So there's a lot to IQ. It isn't measuring just sort of one thing, and there's more than one way of doing an IQ. But I mean, there's a thing you probably have some exposure to called the G factor, and then which is argued to be a potential single thing that maybe, at one point people were like, well, find the gene for that, and the more we get into genetics, the more it looks like that IQ, while there are certainly heritable aspects to IQ, it is yet to be determined to what extent that is genetic versus epigenetic. And recall our conversation about nature and nurture can't really be fully disentangled. We impose a separation of them because that's a limitation of our brains. Okay, so you have fluid intelligence, which is really kind of pattern matching, how quickly, and fluid intelligence are where people often like shine because they're really insightful and they see a problem and they see it before anyone else, and life can be really easy for somebody that has high fluid intelligence. And we in our society we have a tendency to put people up in a kind of competence hierarchy pretty high if they have high fluid intelligence, and there's a lot to the benefits of high fluid intelligence. But crystallized intelligence is sort of a combination of your fluid intelligence, how quickly you can sort of abstract out and see a pattern in something that's similar to a pattern that you've experienced. To what extent can you metaphorically apply something? To what extent can you do that whole embodied spatial navigation in a new terrain in a way that you can map and explicate, and we don't need to get too far into the weeds here, but crystallized intelligence is a combination of how fluid you are and how much you can access of existing memory. Like what do you know? So it is more of the synergy between how fast you can think and how many things you can keep in your head, and how good are you at abstracting out and looking at layers of abstraction, that all those fluid intelligence stuff. At the same time, you're bringing in elements of stuff that you know. And I would argue, crystallized intelligence is far more formidable. You can get a 13-year-old who's got a super genius IQ, but they don't have any knowledge yet. They can do an IQ test where it's all just sort of spatial patterns, and they can just freakishly see the next pattern coming in. But if they have zero life experience and almost no domain knowledge, it's a circus act. But if they can maintain that level of fluid intelligence while they build their KSAOs, then they can become a juggernaut, just super powerful. But there's a limiting thing, which is people with really high fluid intelligence tend to have an easy go of it in life, and they tend to be able to kind of wing it and figure stuff out, and so they often don't develop the habits, and they often don't have quite the mindset that gets them to work hard to build up domain knowledge and the ability of the power of accretion to grow domain knowledge over decades of your life. The synergistic effect of the slowly accumulation of knowledge and the various ways in which you develop associations within your knowledge, that can become extraordinarily powerful, so much so that it becomes less and less important that you have really good fluid intelligence if you have really, really good domain knowledge and access to the domain knowledge. And so that's crystallized intelligence. We're kind of getting off in the weeds here. Well, not really weeds. I like these weeds. They're flowers to me. But this isn't a class where we're supposed to dig deep into G factor, but sometimes I can't help myself. Other aspects of cognition, how well can you access, and I've talked about this a little bit, how well can you access your memory, and how well does your short-term memory, when you sort of take stuff from the hard drive and put it into RAM, so to speak, how sophisticated can you chunk your working memory, and how well can you incorporate new information, and then there's to what extent can you. We all are constrained, and our rationality is bounded, and our cognition is embodied, which means at some level we're we're spatially navigating in an abstract space. That does not mean, however, that it is, say, profoundly visual for everybody, or that everybody can see, with a three-dimensional assembly moving in their head. That is that's not, that is a specific visual construction that requires a certain type of a brain wiring for you to have a really good ability to put that together in your head. And it doesn't, it's not necessarily the same thing. It is just one aspect of a multimodal sensory thing. When I talk about, that we are embodied brains that are navigating in space, even when we're just thinking about stuff, that they're abstracted out ways of acting in the world, even if it's just in our head. That does not mean that everybody has the skills to imagine what a truck engine looks like, and the ability to have good spatial reasoning skills is an important skill for things like if you want to be a technician and work on, you want to be a mechanic and work on trucks. It isn't just hand-eye coordination, because you have to fill in you see some bolts and you see the outer part of the assembly, but you're trying to take something apart, put something together, or you're trying to troubleshoot what's going on. You're actually rendering in your head a whole bunch of the rest of the assembly that you can't see. And when you're tightening a bolt, those threads are actually interfacing with some female threads, maybe deep on the other side of a cast assembly, and you're putting compression on the whole thing. You have to have the spatial knowledge to put all that together in your head in order to do well in that job. And some people just don't have it, or don't have it nearly as well. So it's a big type of cognitive test. So you might, your fluid intelligence, for instance, could be off the charts, but if you really struggle at imagining spatial things in your head, you might be a horrible mechanic, or you might be a horrible mechanical engineer. But maybe, depending upon what you get into, you could be a really good software engineer, depending upon how your brain works. That's sort of a different type of relational thing. But all right, I better get going here so I don't make your lecture too long, because I'm nerding out about intelligence levels. Speed, how fast you can think. Verbal fluence, the extent of your vocabulary, the ease with which you can access your vocabulary, how well it makes sense to other people. Words are powerful abstractions, and at some level, it takes a lot of intelligence to convey a difficult topic with simple words, but at the same time, fancy words, polysyllabic words give you new conceptualizations that actually help you construct your knowledge and help you navigate the world. So, anyway, let's get out of this. A really important thing here: intelligence is not wisdom. It really isn't at all. And the wisest people are not always the smartest, and some of the smartest people are fools. That doesn't mean that these things are in opposition. Quite the contrary. And intelligence is a means to acquire wisdom. But it isn't a guarantee, because of the power of intelligence to construe. And the really, really smart people often end up developing the most complex justifications for the current binding narrative, which I've talked about in past lectures. And they aren't necessarily the ones that can sort of see through what's going on and cut to the meat of it and
bring a value framework, properly prioritize a value framework. So intelligence and wisdom are not the same thing. And depending upon what you're doing in your organization, in many cases you want wisdom and you want good judgment, but it sometimes comes at a price of maybe somebody that doesn't think quite as fast, or maybe somebody that isn't quite as verbally fluent. And we tend to simplify in our society, and we tend to exalt people that are incredibly verbally fluent or have really amazing fluid intelligence, or both. And we tend to conflate that manifest behavior with wisdom. And I would implore you not to do that in your life, and to cultivate both, to try to maximize your various dimensions of intelligence, and try to maximize your wisdom, and to recognize that they're not the same thing. So getting a little bit back to IO here, and a little less in the weeds. The part of job analysis, part of determining the KSAOs needed for a role, it will help direct the selection tests to determine what, if any, cognitive type tests are necessary. And as I mentioned, if you want to be a mechanic, and some company or a repair shop or whatever, some dealership is considering investing the considerable amount of time doing on-the-job training for you, it would be very appropriate for them to basically give you a spatial reasoning test that might even be physical, because it turns out you have poor spatial reasoning skills. It might be a big waste of everybody's time to try to give you on-the-job training. So similarly, if you're going to be a back-end software developer or software engineer, the back-end people might not like the term developer. I think it's kind of it's a strange world. The ability to have good memory and good crystallized intelligence, the ability to basically put order of things in your head, because coding, you impose the structure of the code in your head. Anyway, we're getting in the weeds again. It should make sense to you that if you're going to do job analysis and you want to use cognitive tests, that you want to be careful to make sure those cognitive tests are very relevant, and then you want to be very careful about using them too much as a filter, because it's not the same as wisdom, and it can really exclude people who otherwise might do really good on the job. There are people that if they had the time, if you gave them the time in your organization for them to develop the experiences needed so that they can do the generalization in their head and develop the wisdom, that they could be truly excellent performers, but it might take you longer as an organization to invest in them to get them to that level, whereas sometimes you have people that have really high cognitive ability. They don't need all of the examples because they have the ability to sort of generate other hypothetical examples in their head and see the connections between them, and make quick pattern matching, and they can kind of get it and develop what looks like judgment real quick. But sometimes those people leave because you don't pay them enough. Sometimes those people get overconfident. It isn't all, and sometimes they are too smart for their own good, and they don't exercise judgment when it really, really matters, because in their world they can understand everything. So it isn't like somebody that takes more time is for sure a more expensive investment than somebody that can learn things quicker. Sometimes the people that learn things quicker can also cost you in different ways. So it's really complicated. and nobody's figured this out yet. But I would encourage all of you to it's good as a society that as a society we consider intelligence to be something that we admire and that we recognize as a hierarchical dimension of competence. But it's also important that we recognize a hierarchical dimension of wisdom and judgment, and recognize that they're not the same. Okay, that's enough about that. Let's try to wrap this lecture up in the next 5 minutes. And in order to do that, I'm going to have to stop myself from talking about a topic that I'm super interested in. And I could talk for hours or days on both cognitive, on intelligence and personality, but we're just going to breeze through it because it's not central, but it is peripheral, and it is something that you should have at least some background in. So personality traits, they don't always predict states, which is to say that the traits are tendencies. If you're super extroverted, that doesn't mean you're extroverted every time in all situations, that you're never ever silent about stuff. And likewise, if you're introverted, that doesn't mean that under no circumstances do you ever actually talk. What it does mean, what a trait means, is that over time, if you're highly extroverted and somebody else is highly introverted, that over time, in enough situations, a pattern will emerge where the introverted person will be less likely to be highly expressive, where the extroverted person will be more likely. But it's very difficult to create a circumstance to use one situation and have that be predictive of personality, because there's so much variability at play. So the 5-factor model is the most common trait model. This is an interesting field with a lot of argumentation over frameworks, and people arguing things like traits don't exist. But generally speaking, within the personality psychology field, it's generally agreed that there are 5 traits, five ways in which you can consistently dimensionalize people's individual difference behavior, not the only 5, but that these 5 are pretty consistent to be and recognizable, and those are extroversion, agreeableness, conscientiousness, neuroticism, and openness/intellect. I put them in this order, so you'll hear them. You'll have people spell out ocean, OCEAN, as a way to memorize that, but I don't like doing that because it puts it in an order that isn't really appropriate. I put it in this order, and I use the term EACNO, 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 because this is the order in which they are most predictive, that their effect size is strongest. And when you create an experiment, or when somebody is highly extroverted, it is the thing that can show up the easiest, and agreeableness is the thing that can show up second easiest, and openness, for instance, is the one that is has the smallest effect, and it's harder to predict. So important thing from a work standpoint is conscientiousness is the biggest predictor of job performance, and that shouldn't be a surprise, considering the short version of conscientiousness is hardworking, and it's not that simple. There's people that break it down into things called, there's facets and aspects, and people argue about it, but some say that conscientiousness is broken down into industriousness and orderliness and that sort of thing. But the bottom line is, generally speaking, conscientiousness relates to how hard you're working. Whether that's from an approach motivation or it's avoidance motivation, you're still working. So a highly conscientious person is somebody that's the hard worker, and that correlates with job performance. To a lesser degree, agreeableness tends to, high agreeableness tends to be pro-social, tends to help with group performance and that sort of thing. But for the most part, with the exception of conscientiousness and a little bit of agreeableness, most of this is sort of spice. This is the difference. And in group situations, there's a good argument can be made that the differences in personality help move groups in a way that they help to make better decisions. You get more wisdom of the crowd effects that way. and this is part of the multidimensionality of humans, that everybody's got a unique personality that itself combinatorially cuts across at least these 5 dimensions. And you will in your work experience have to deal with all sorts of different manifestations of these, and just knowing how to dimensionalize them and knowing that people are different can actually help make you more accepting and less expecting of specific types of behavior, and more appreciative of the variety of human behavior. There's other models. There's what's called Hexco, which is very similar to the Big Five, but it's really uses 6, and we don't need to get into it. And then there's companies that have their own proprietary models, some of them good, some of them not, or some of them decent, and some of them junk, depending on how you want to look at it. And they're proprietary in the sense that they've made their own, they've done their own studies, and they'll sell them, and they'll do their own assessment, and they're in the business of making money. So their assessments are not things that they share, and I'm not a fan of those, because it's hard to get into the literature of it to see how valid they are, how reliable they are, so to speak. But you'll run into them quite a bit in the workplace. And then read up on Sackett and Walmsley in the textbook, please. Okay, some other tests quickly here. There are tests that can be performed to somewhat assess people's how rigorous they are about honesty, and the things that might be somewhat predictive of integrity. And some of that's directed towards trying to reduce the probability of theft in the workplace, and measuring other counterproductive work behaviors. And you can ask them overt questions, trying to get at, are they really sticklers for rules, and to what extent do they bend the rules? And then you can even create tests that that people will tend to. You're not going to ask a question, is it okay to steal a lot of money from work? Nobody answers those. Even a thief will not answer that directly, but there's ways you can contrive stuff to improve your probability of catching somebody who's clearly putting a certain kind of face to their answers, and it's it's not an exact science. And then you can look at aspects of personality as well, but those are difficult to do and make valid. There's judgment tests. What would you do in this sort of situation? And some of that would be how risk averse somebody is, and how likely they are to let a higher authority take over versus jump in and do it themselves. And in some cases you want one or the other depending on what the situation is. There's various things for skills. You can do specific job-related situations or job simulations and look for judgment. There's aptitude, which is really KS, knowledge and skills. There's looking at people's experience. And so this is the classic thing. You got a resume, you got some profile on LinkedIn or whatever, your biographical information. And then you get a little bit detail and sort of combine that with things like a big personality inventory. And delve deep into the past experience to get way beyond the resume, way beyond like something like a CV, and also do a battery of individual difference tests and develop a biodata inventory on stuff. So you end up with something that's highly systematized, detailed. It does take a long time. Done right, this is considered valid, but boy, it's expensive. It can be a valid way of assessing, but doing this with every single applicant can be very prohibitive. Okay, some concerns about testing: ethics and privacy. You need to make sure that these work, they're designed by experts. You need to make sure that the test results aren't just given out to everybody. These are private things. And that you only use these tests specifically for what they were designed for, or what they're valid and reliable for. You can do harm to your organization and potentially set yourself for liability if you're sort of using them off-label, so to speak. And then gaming. Candidates can fake their answers and tell you what they want to hear. And psychological tests are imperfect. There's no test that's perfectly valid. And because of that, you end up with qualified candidates that are rejected. People that, had you hired them, would have done fine, or perhaps would have even done better than who you thought was most qualified. These are imperfect things, and you can't just use them uncritically. Don't assume that they are these perfect things that you and that therefore you need to completely shut down any of your implicit wisdom. You want to recognize that, at least in time, with good observation, you can develop implicit knowledge about what makes a good person. The problem is you can't make that explicit. You can't objectify and scale that, and that's kind of the rub. Is how do you balance that? Okay, we're hour and 5, so I owe you a short lecture in the future. Let's recap. We talked about psychological tests for work specific for selection. We introduced a number of fancy words related to validity, but keep in mind the concept of validity is important, and it's the most important thing that a test is that it actually tests for what you think it's testing for. Almost as important is reliability. We talked about different methods. We talked at length, perhaps too long, on cognitive tests. And we talked a little bit, and I would have loved to talk a lot more on personality. And we just got done talking about some other tests. Okay, so for lecture 11, our next lecture, we will be, as part of the chapter, this should be chapter 4, we're going to talk about interviewing. And those include unstructured interviews, structured interviews, interviews that are based on situations, and other interview types, and other factors used for selection, and sort of what is the selection process workflow, and then a little bit on what does it take to be a great interviewee. All right, that is the end of lecture 10, and I will see you at lecture 11. Have a good one.